This is number 1 from the book, from the practice AP questions at the end of chapter 3. What do you have to see here? So here's the first hint. When you see that and that, you should think definition of derivative. Doesn't mean for sure that it is definition of derivative, but it's a big hint that it could be. So be aware, you need to look at that. What is the definition of derivative with h approaching 0? It's this. The derivative is the limit as h approaches 0 of f of x plus h minus f of x over h. So if you look, that limit and h match. So you should be thinking, hey, this might be the definition of a derivative. So the next step, you would say, well, x plus h, if that's true, does that match this, x plus h? It does if x is 2. So what it appears, this is the derivative not at x, but at 2. So it would look like this. F prime at 2 is the limit as h approaches 0, f at 2 plus h minus f of 2 over h. Now we have to make sure it matches that form. So if you look at this 2 plus h, what would it be? That would be your x in the function, so it's 3x squared. So that would mean your f of x is 3x squared. Does that match? Well, the question is, what's f at 2? That'd be 3 2 squared, or 12. So now let's see if everything works. F at 2 here is 12, and it matches with your f of 2. And f of x plus h, or 2 plus h, excuse me, you'd put a 2 plus h here, it would be 3 2 plus h squared. So this is the definition of the derivative at 2. So once you see that, we say, hey, what's the derivative of f of x? Well, the derivative of that using the power rule is 6x. Now, I want the derivative at 2. That's going to be 6 times 2. That will be 12. And so this is the derivative at 2, but this is that. So this is the derivative at 2, which we just found out is 12. So the answer is 12.